pleasantly surprised and happy for a change.
That's a lie.
That in 9.2 is a relatively simple thing to do. They even have the word simple in the title.
9.2 is an easy thing to do.
Bless you. So in this case here, what I'm looking at doing is we're going to be graphing some very simple rational functions. Now, what I want to first of all do is show you guys what a rational function looks like. A rational function is basically going to be the following. Any rational function is some f of x, otherwise known as
Y.
Some polynomial divided by some other polynomial. Okay, it's some polynomial divided by some other polynomial. Okay. Now, the way that the book and everybody else writes it is this: f of x for a rational expression is some p of x divided by q of x, where p and q are functions. That's all it is, and they're polynomials. Excuse me, they're polynomials. That's all.
I'm really grateful for the fact that you always rewrite it in a way that we can understand.
I try to. No. I try to do that because you know what? You're right, Claire. A lot of the stuff that you guys read, it's in math, it's so technical. But what does it mean? Why not make it easy for you to understand what it is? Because that when we see the technical, you go, oh, I get it. So what we're looking at doing here is we're going to take some polynomial. Remember, polynomials can be anything. It could be x plus 1, x to the third minus 2x squared plus 3. It could be any of those. But we're just dividing them out. Okay? So we're going to look at something like this. We're going to look at that kind of a graph. Reaction to polynomial.
Slow down there, cowboy. Bring the cows back in the barn. Oh, so would it be
What do you mean x over 1?
3x over x?
No, you can't simplify here.
Stop.
You see that big thing that says addition? So we're going to look at stuff like this. I am too. We're going to have two types of equations today. We're going to have one that's going to look like this: y equals something over x minus h plus k. You're going to get two forms of equations today. We're going to talk about this one with an h and k, and we're going to talk about a different one that does not have that. What we're going to do is identify parts. And if I'm looking at this, there are some things that you can and cannot do with fractions, if you will.
Fraction, another fraction, like we had to do last night.
You can do that. Now, what is one thing you can't divide by?
0.
0.
You cannot divide.
You cannot divide by 0. So what happens when you have something in your denominator that equals 0? Remember, it didn't work. You had an undefined slope if you were finding slopes. Okay. One of the things that happens if you do that graphically is that it creates a what?
Vertical.
What is that called? You're right, it's vertical, but what is it going to be? What is that thing called? What does that stand for? No.
I was saying what
Asymptote. You better know your asymptote for a hole in the ground here, guys.
What? I'll tell you.
You get what are called vertical asymptotes and horizontal asymptotes. Okay. You get. Yeah. So we're going to work with this model here that has vertical and horizontal asymptotes. All these rational functions that we're going to look at are going to have both of them. They're going to have vertical asymptotes and horizontal asymptotes. Vertical asymptotes are when you get 0 in a denominator. You can't have that. 0 divided by 0 is bad. So your vertical asymptote is when denominator equals 0. And that is bad.
Yes. I think process.
Okay. So you don't want to have 0 in your denominator. And your horizontal asymptote is just move left and right. Now, what happens here with this generic form is that your vertical asymptote is always going to be x equals some number. The 0 of this, if I set the denominator here equal to 0, what would the 0 of x minus h be? H.
Oh, wait, yeah, that's
Okay? And your horizontal asymptote is always going to be this tail number, whatever that is. It's going to be y equals k. Remember, when you're finding zeros from a term, you just flip the sign, and then your k value is just whatever it is. So if I'm looking at the example that I had up top here for a second,
Wait, so x is always true?
your asymptote is always the 0 denominator. Look at the example.
Oh, so like
If I have the example there, set this equal to 0, solve for x. What do you get? H.
Because if x equals h, that's h minus h.
Watch the example here. If I go back up top here, what's my a value? Negative 2. What's the 0 of x plus 3? Negative 3. See what you're doing? You're just finding the 0? If your term is x minus h, your 0 is h. That's what that means. Right, you get an asymptote, because you can't divide by 0.
Do we want to get asymptotes? So do you always set y equals 0?
It's bad. You can't have an asymptote. You can't divide by 0.
But do we want an asymptote?
Why can't we
not
Do you
want
remember me saying 3 minutes ago that all of these graphs have asymptotes? This is how you find an asymptote. At some point in time, yes, you will have an asymptote. Every graph that we do today has an asymptote. How do you find the asymptote? You find the 0 of the denominator. That's all I'm doing. Okay? What's k? Negative 1. So if I'm looking at it graphically, oops. Our a was negative 2, h is 3, k is negative 1. If I'm looking at it graphically to figure out what this is going to look like, I have a vertical asymptote at 3. Was it x plus 3 in the original? Sorry, I was just trying to memorize it.
Nice.
I think that was a lot more work.
And if I made it look cool.
Yeah. So I have a vertical asymptote now at negative 3, if I was writing the right problem. I have a horizontal asymptote at negative 1. Notice what I just did. I labeled them. Okay? Now, the rest of this, I don't know what it looks like, but what could I do to figure it out? Put in your calculator. Put in your calculator. When you put that in your calculator, your y equals. Oh, first of all, you guys probably need to clear out what you had in there for right now. From 6.9, you guys are doing all that stat plot stuff. What I need you to do right off the bat is go second y equals, go to your stat plot, turn it off. Okay. Turn it off. And to do that, you just hit enter on your first one and just make sure your cursor is on off. Everybody get that okay? Okay. Go back to your y equals then. When you go back to your y equals, remember how you put a fraction in?
Alpha y equals.
Alpha y equals. What do you got? I think so, yeah. I'm not sure. I don't remember off the top of my head. I don't really stat out very often. So then you just put it in, what was it, -2 over x plus 3?
I missed these tools.
Wait, what should we have our window at?
Go back to your window at a -10 by 10. Okay. You probably have to rechange that as well.
Like 2,000. Oh, you I don't know. I really don't know.
So what is that graph of?
It's a hyperbola.
It's like a
diagonal.
diagonal. Oh, that's what you were talking about yesterday when you said the thing.
These are, if you think about what we've done in the past here, this is the hyperbola that you did before that looked like that. Up or down.
But now they're standing.
Now they're just sideways. All of your asymptote, your slant asymptotes you did before have become vertical and horizontal asymptotes.
That's
Yeah.
so cool.
You've actually graphed this before, but it was in a different form. You graphed hyperbolas in that a, h, and k form with the x squared quantities. This is a little bit different when you're talking about in terms of rationals. Rationals just look different. So your graph is like this, and I'm going to cheat.
Very realistic.
It's close. And then I'll just put in my asymptote here at -3. And then I have one here.
That's realistic.
It's close-ish. Now, the only other thing you have to worry about doing here is finding a couple sets of ordered pairs on both curves.
Yay.
And how do you do that?
Go to the table.
You go to the table. What I'd like you guys to do on these types of graphs then, is obviously you're going to be using your calculator to get your curves. And then it's just a matter of you're looking for some ones that look to make some sense. Some of them will. It depends on how your settings are. You'll get some, every once in a while, these are going to have, you might get one or two clean numbers, and you might get one or two nasty numbers. Try to use the clean ones just because it's easier just to plot. Okay? So if I'm looking at this, I know I have -2, -3, -1, -2. Those are my ordered pairs there. And then I have my other ordered pairs here at -5 and 0, -4 and +1, and I just plot those as well. Okay? It's a matter of using your table to list them out. Yes, sir? Yep, that's all it is. Remember, your curves are going to be hugging the asymptote, go through the sets of ordered pairs that you did. It mirrors the same idea of when we did the hyperbolas in the conic section. Remember, we would hug the asymptote, and then we would go through the vertex. Or, yeah, go through this vertex. Yeah, go through the vertex and then go through the other asymptote. It's along the same lines. Okay, it's along the same lines. Not bad, is it? What's wrong? The table's giving you ordered pairs, so you can have points to plot. You can have to put you have to put 2 points on each curve.
Oh.
That's all. And you don't have to try and do it by hand. Use the table, just put a couple points in.
Okay.
That's all. Yes, sir.
So
Table isn't the same.
What's that? What does it say?
Table.
What is it saying? Did you type the correct equation in correctly?
The number 3 for pairs.
You didn't type it in. I asked you to turn it and type it in correctly. Right? All right. So like I said, it's not like it's real tough stuff, but it's just what we're looking at. Have you guys try one? Oop, got this one. There we go. Take a second and do this one. Remember, when you're identifying and graphing these things, your job is to plot your asymptotes, plot and label your asymptotes, I should say, and then give me two sets of ordered pairs on both curves. And that can be done by your calculator. Okay.
Mr. Murphy?
Yes, sir.
One day will these things be like $15 left over there?
TI, the graphic calculators have been the same price since I was in high school.
Wow, really?
Seriously.
That's kind of crazy.
It is. I think the first graphic calculator. All right, who sings it?
Survivor. Yeah.
It was great how I timed that for the last
Yeah,
Who
that's what-
sings it?
And I thought my mind was just like playing games with me and like
More so
telling
than
me.
normal? You get H. I'm sorry. That's perfect. H and K, so we got -1, 4, and 3.
Yes.
So your horizontal asymptote is at, or excuse me, vertical asymptote's at 4. Horizontal asymptote is at 3, so x equals 4, y equals 3. Now when you go to put in your dots, your curves here, it's just using tables. And if I'm not mistaken, this is second and fourth quadrant-ish, I believe.
Yeah.
And then you can label your ordered pairs, right?
Yeah.
So let me show you the other form then. The other form is a little bit different. This form is a little bit different. I don't know why you don't need any hints. You don't need no sneaking hints. Hints? Badges? Badges? We don't need no stinking badges. That's Spanish. Yo necesito un español el clase. The other form in this case looks like this. Y equals AX plus B over BX plus D. One of the things that you'll notice, sorry, it's supposed to be C. One of the things I want you to see, to notice here is that there's no H and K. All right, there's nothing tacked on to the end of this. Also, the difference between these two forms is that there is a variable in both the numerator and in the denominator. Okay, that's the main difference between the two. In the first form we looked at, there's only a variable in the denominator, and the other form there's variables in the numerator and denominator. So when you go to figure out what your asymptotes are, your vertical asymptote is going to be at the 0 of the denominator. It's where you get 0 for x. Okay? You solve for x. Think of that cx plus d as a term, and you're just going to tell me what the 0 is. And that's going to be your vertical asymptote. Your horizontal asymptote's a little bit different then. The horizontal asymptote is just taking the, y equals a number because it's horizontal. All you're doing is taking the coefficients of the leading term. A over C. All right? When you work with this form, you're going to be very, very surprised at how simple it is. Yes, sir? Yes, sir. You can write them a couple of different ways. It's just the way that the polynomials work, because if you look at the degree, this works because they're both degree 1. Right. Whereas the other one, you have it set up a little bit differently. Right. Now, real easy example of this form. Let's say we have y equals 2x minus 1 over 3x plus 4. And I want to identify my asymptotes, give a rough sketch, and a couple of points. So if you have y equals 2x minus 1, my vertical asymptote going to be 3x plus 4 equals 0. And what's your 0 for that?
Minus.
-3/4.
Negative
4
4.
over 3.
Oh.
Subtract 4 divided by 3.
Oh, duh.
Okay? Subtract 4 divided by 3, so your vertical asymptote will be at x equals -4/3. Your horizontal asymptote then is 2/3. Very good. It's just pulling the coefficients. Sometimes those coefficients, sometimes those will be able to simplify, other times they won't. It's not a big deal. And then when you go to graph it, again, what you're looking at doing is just using your alpha y equals to create a fraction bar in your y equals form and get some points. X equals -4/3, so that's a little bit more than 1. 2/3 is a little bit less than 1. Oops, not that. If I'm not mistaken, when you do your order pairs on this one, would you get basically first and third quadrant?
Yes.
And then just obviously listen
No,
out.
no, no.
Am I backwards?
Yeah.
It's
Yeah.
second and fourth.
It's 2 and part. It doesn't really go in the fourth quadrant. Well, it goes like above it.
So in the first quadrant?
Yeah. Yeah, that's exactly what it is.
Sorry. It's just a matter of plotting out some points.
No.
Like I was saying the third hour, you should be should be pleasantly or should be happy with these problems. Yes, sir.
Does it also have it only in one section?
No, it won't be, because even if you're in that first quadrant, you got a tail. If this was coming down here, isn't that going to eventually cross down in the second? So you could have that. Give me a couple of these to try. Do you want graph paper?
Yeah.
Would you like? You want graph paper to do this? The couple of graphs, you can use it. You don't need to. I'm not going to yell if you don't use graph paper. It's not a big deal. These do get a little bit more complicated come Monday. Come Monday, we're going to try and talk. We're going to talk about some of the other weird style things that happen. But for today, this is pretty straightforward. All right.
I use graph paper.
Who's in a lot of problems?
I don't know.
You got like 15 minutes and there's like 15 problems. I know.
11 minutes.
When?
Oh, wait, is the abbreviation for pages PE or PG, or does it matter?
It doesn't matter.
It's up here.
I just write page.
Use that graphic.
Hey, Allie.
Uh,